Advanced Algebra 2, Concept 10, Solve Quadratics using Factoring. All right, I'm going to start with this graphic from our Concept 9 notes to help you see that now we're moving to the second method, solving by factoring. Remember that factors are two things that you can multiply together to get what you started with. So when we factor a quadratic, we're looking for two polynomial expressions that you can multiply back together to get that original quadratic that you started with. So when you're solving a quadratic by factoring, you are essentially rewriting it in intercept form. Factoring undoes the multiplication method, and so I'm going to refer to FOIL method. So you may have learned this. This is just an acronym that when you multiply two binomials together, you multiply first terms together, then outer terms, then inner terms, then last terms. And then finally, when you're factoring a quadratic, after you have factored it, then we can set those factors equal to 0 and solve using the zero product property. So the zero product property in words is if the product of two expressions is 0, then that means one or both of those expressions need to equal 0. So in algebra, if you have two things multiplying together like a and b, and they equal 0, then you set a equal to 0 and b equal to 0 and solve both of them. Now there is a process to factoring a polynomial. So the first step is that you're going to look for a greatest common factor. And in algebra, we usually call that the GCF, greatest common factor. It can be numbers or variables. And you do that, you factor out a greatest common factor if possible. Then the second step is you look at how many terms you have or you have left after factoring out the greatest common factor, because this gives you direction on how to factor. If there are two terms and the terms are being subtracted, it's a difference, you're going to look for a difference of squares, that pattern. Two things that have been squared that are being subtracted, because you can factor or break those apart into a plus b times a minus b. And we'll look more at that more in depth in a little bit. You also want to see if there are three terms. Then we're going to look for what we call trinomial factoring, level 1 and level 2. And this notes video will take you through how to do quadratic trinomial factoring, level 1. And then step 3, if you need to solve, then you're going to set each of these factors equal to 0 and solve. And you'll either get your two solutions or one solution. So before we start factoring though, let's work the other way. Let's multiply. And we're going to multiply using the FOIL method. So again, that's just an acronym. That means we multiply first terms together, then outer terms together, inner terms together, and last terms together. So our first terms together are x times x. So I'm going to draw my line. And then my outer terms are x times 2. And those are positive, so I string them together with my a plus sign, so plus 2x. My inner terms together are 5 and x, so 5 times x is 5x, and then my last terms together is 10. Now I'm going to go ahead and combine my like terms, so I get x squared plus 7x plus 10. Now I want you to take a look for a moment at the two numbers in the expressions we multiplied, 5 and 2. There is a relationship between the quadratic that we end up with, x squared plus 7x plus 10. Notice that when you multiply 5 and 2 together, you get 10. So that value is at the end is the number that if we multiply our factors together, we get that one. Then if you look at our middle value, which is our in ax squared plus bx plus c, our b value, if we were to add or combine 5 and 2. So let's see if this pattern holds. Let's multiply x minus 12 times x plus 3. So x times x is x squared. X times 3 is 3x. Negative 12 times x is negative 12x. and negative 12 times 3 is negative 36. Now let's combine our middle terms, x squared minus 9x minus 36. And then examine your two factors in the expressions negative 12 and 3. Notice that if you multiplied those together, you would get your c value in your ending quadratic. And then notice if you added or combined those together, you get negative 9. Let's try another. Let's FOIL x plus 2 times x plus 11. So x times x is x squared, x times 11 is 11x, 2 times x is 2x, and then 2 times 11 is 22. And now let's combine our like terms, and then let's examine. So 2 and 11, sure enough, if you multiply, you get the c term, which is 22, and if you were to add those, you will get our b term. Now let's put some negatives, two negatives in the mix, and see what happens. So x times x is x squared, x times negative 8 is negative 8x, negative 7x, and 56. Combine your middle term, and then examine those two factors. So negative 7 and negative 8. Yes, if you multiply, you get 56. And if you add them, you get negative 15. All right, we're going to use that pattern to work backwards. To start with the quadratic in standard form, ax squared plus bx plus c, and work backwards to our two set of parentheses that we can multiply together to get that. So if we look at the first one, notice, let's think in terms of a, b, and c. So a is 1, b is negative 4, and c is negative 45. Now I'm just going to use a simple x to organize my numbers. In the top part of the x, I'm going to place my c value. So I know that I need to find two numbers that will multiply to give me the c value. And then just down below, I'm going to use that to place my b value, negative 4. So I'm looking for two numbers that multiply to give me negative 45 and will add or combine to give me negative 4. Now think about a pair, and I like to think not in terms of the negatives. So I leave those off for a moment. Multiply to give me 45, and if I added or subtracted, I'd get 4. So you may be thinking of 9 times 5. So I'm going to place 9 and 5 in the two spots that are left. I realize if I make my 9 negative, that now I have a complete picture. Negative 9 times 5 is negative 45. Negative 9 plus 5 is negative 4. So now I know my two numbers that are my factors that go in my two parentheses expressions. Since that my first term is x squared, that means I have x minus 9 times x plus 5. If you were to FOIL that back, you would get x squared minus 4x minus 45. Notice now that we have it set equal to 0, so that means we need to go ahead and solve. So using our zero product property rule, we're going to set each of those factors, x minus 9 and x plus 5, equal to 0, and then just do the simple solving. So our two solutions for this quadratic are 9 and negative 5. That means if we graphed this, it would open up and it would cross the x-axis where x is 9 and where x is negative 5. Now let's look at number 2. So notice we have x squared plus 12x plus 35. So remember, we're looking for two numbers that will multiply to give us our c value, 35, and will combine to give us 12. And I just made a note on number 1 that these are our solutions, or our x-intercepts. So two numbers that multiply to give us 35 and will combine to give us 12. So 5 and 7 probably jump out at you, and let's just write those numbers in our two remaining places. So multiply to give us 35, add to give us 12. 7 and 5. So those are our two values that go in our parentheses. X plus 7 times x plus 5. And we know that that will work because if we were to FOIL that back, we would get x squared plus 12x plus 35. We have an equal 0 at the end, and so that means we need to go ahead and solve. So we're going to set each of these these factors equal to 0 and then solve the equations. So x equals -7 and x equals -5. So -7 and -5 are the solutions to number 2, this quadratic, and the x-intercepts. If we graph this quadratic, it would cross at -7 and -5. Now let's look at this one. Notice that we have a common factor of 2. So I'm going to factor that out first. Then I'm going to focus on what I have left, x squared plus 8x plus 16. So I'm looking for two numbers that will multiply to give me 16 and combine to give me 8. The pair 6 and 2 probably jump out at you. Or, sorry, I meant 4 and 4. So that means in our two parentheses expressions, we will have x plus 4 times x plus 4. Notice I brought down the common factor of 2. So if we were factoring, we would give the answer of 2 times x plus 4 times x plus 4. We're going to go ahead and solve. So the first thing we would do is divide both sides by 2. And then we can set, in this case, since these are identical expressions, x plus 4, we only need to set one of them equal to 0. So this is a quadratic that only crosses the x-axis at one point, at -4. It just touches down. That is its vertex. I'm going to continue the Concept 10 Quadratic Factoring Level 1 in a Part 2 video. And in that Part 2 video, we're going to firm up the steps to how to recognize a Level 1 quadratic and how to factor it.